Okay, section 2.5. We're supposed to use the graph below. I'm going to have to lift that up there a little bit so we can see it all. And we're supposed to find the indicated derivatives down below here. So h prime of 1. And h was f of g of x. So h prime is going to be derivative of the inside at 1 times derivative of the big picture, which is going to be f prime at g of 1, leaving the inside alone. So g prime at 1, g is the, f has the corner, and g is this one. So g prime at 1, well, that's the slope of this. G prime doesn't change from 0 to 1. It's always 0 to 4. It's always down 1 for 4, so minus 1/4, slope of negative 1/4, times the slope of f at g of 1. Now, at 1, g's value is 3/4. This is 1/3. So g of 1 is 3/4. We got to find the slope of f at 3/4. Well, 3/4, the slope of this thing is, looks like it's going up 2 for 1, which is negative 1/2. Now h prime at 2, so now I got to do g prime at 2 times f prime at g of 2. G prime is negative 1/4 times at g of 2 is 1/2. So I got to go to 1/2 and see what the slope of f is. Well, it's still 2. So it comes out to be 2 times negative 1/4, which is negative 1/2. And finally, h prime of 3. So I got to do g prime at 3 times f prime at g of 3. G prime at 3, the slope is negative 1/4 times g of 3 is 1/4. So I got to go to 1/4 and go to the f and find its slope. It's 2. So I got negative 1/4 times 2, which is negative 1/2. Now let's do number 9. Let u be differentiable function. For the following functions, each response will involve a u or a u prime. So the inside, this is a chain rule. We got e to something, and we got to take the derivative of the inside. So that's going to be u prime of x. You can put the x there if you want. Times the big picture, which is e to something. Its derivative will still be e to something. Now this one's a product rule. Or no, this is u of this. So the inside is e to the x. So the derivative of e to the x is e to the x. That's the derivative of the inside times the big picture, which would be u prime, leaving the inside alone. Okay, so we got the cotangent of something. So derivative of the inside is u prime of x times the big picture secant's cotangent's derivative is negative cosecant squared of whatever was on the inside, which is u of x. So you get the derivative of the inside times the derivative of the big picture. Cotangent of something is negative cosecant squared of the something. Okay, Now we've got u is a function of the cotangent, so the derivative of the inside is cosecant squared x. That's the derivative of the inside times the derivative of u with the same inside that it had. Now we have u of this is the inside, so the derivative of the inside is 4x cubed times the derivative of u with the same inside as it started with. Now x is inside u to the fourth, so the derivative of x is, actually that would be 1, but then we have u of x to the fourth. It's just written with a 4 in the other place. So the inside is u of x, so its derivative is u prime of x times the derivative of the big picture, which is 4 u of x to the third. You can write the 3 here or 3 like they did there. So it's the derivative of the inside times the derivative of the big picture. Okay, 10. So on 10, we're supposed to find these things down at the bottom. P and Q. P is this one. Q is this one. So we got to find the derivative of this. So that would be the derivative of the inside, the slope of Q, times P slope at Q of x, leaving the inside alone. So if I'm going to do this at 0, the slope of Q is 0 times the slope of P at Q of 0. Now Q of 0 is not 0. Q of 0 is 2. So times the slope of P at 2. And the slope of P at 2 is plus 2. So, but that's still going to come out to be 0 because that was 0. Now let's do it at 3. So the slope of Q at 3, Q's slope at 3, and its slope is -1, times, now I got to put in 3 into Q. 3 into Q is 0. Then find the slope of P at 0. And P's slope at 0 is plus 1/2. So this comes out to be -1/2 for that one. Now let's do the next one. So what values does C prime not exist? So we have to be able to find the slope of Q. We can't do that at -1 or 1. So does not exist at -1 or 1. But we can't find the slope of P at any Q. We have to be able to find the slope of P for some Q's. Now P, we can't find the slope at -1 or 1. So we have to know, when does Q give us -1 or 1? Well, Q gives us -1 at -2. So at -2, Q of -2 is -1, and we can't find the slope there. So we can't do -2. And Q is also 1 at 1 at right there looks like negative 1 1/3. Because at 1 1/3, q of negative 1 1/3 is 1, and we can't do the slope of p at 1 because of the cusp. And we can't do it the other place q is 1, which is at 2. So we cannot do c prime at the obvious, negative 1 and 1, but the not so obvious is, which is where q is negative 1 or 1. And now, finally, q of x, so that's going to be q prime of x, that's the derivative of the inside, times q of prime of q of x. And this one's going to be p prime of x times q prime of p of x. So we're supposed to do this one at negative 2. So q prime at negative 2, q's slope at negative 2 is plus 3. And q at negative 2, q of negative 2 is negative 1, and q prime at negative 1 is not possible. So does not exist. Now let's do p prime at 0. The slope of p at 0, p is this one, the slope at 0 is 1/2, times, now p of 0, p's value is negative 1/2. The slope is positive 1/2, but the value is negative 1/2. So we have to find q prime at negative 1/2. At negative 1/2, q prime, the slope of q is 0. So this comes out to be 0. This one doesn't exist, and that one's 0.